Alright, today's lesson is going to be over multiplying complex numbers. Now, before we get into multiplying complex numbers, the first thing we need to talk about is I squared. We know that I is the square root of -1. But what will happen if I square the square root of -1? Now remember that square root and square, they are inverses of each other. So what happens is the square root and the square will cancel each other out, and I will get that I squared equals -1. So that's very important because when we multiply, we're going to multiply two imaginary parts together and end up with something I squared. So we'll have to convert that I squared to a -1. Alright, so how do we multiply complex numbers? Well, when we multiply, this is similar to multiplying binomials. We need to distribute into and multiply each part. Now, you might call it FOIL. You might use the box method. It doesn't really matter as long as you remember to multiply each piece to each other. So let's say, here's an example of two binomials. And I need to multiply this x to both the 2x and the -1. I also need to multiply this 2 to the 2x and the -1. That's the distributive property of multiplication. However, sometimes I get lost and forget, what am I supposed to multiply? Did I already multiply that? Or what do I need to do? So, I would, if you want to, you can use FOIL, which says multiply the first terms together. So that would be x and 2x. The outer terms, -1 and x. The inner terms, 2 and 2x, and then the last terms, 2 and -1. However, there is another way to do this, and I call this the box method. This helps me organize my thoughts. So I'm going to put x plus 2 on the top, and then 2x minus 1 on the side. What this helps me do is remember there are 4 multiplications that need to happen. So 2x times x will be 2x squared. 2x times 2 is 4x, x times -1 is -1x, and -1 times 2 is -2. Now what's nice about this is that the organization that follows, these two here, 4x and -x, are like terms and can be combined. So I simply write 2x squared plus 4x and -x are 3x, and then minus 2. So that's how you would multiply two binomials. Now, why did we do that? Well, because complex numbers are done the same way. Okay? So I can either use the box method or the FOIL method, but what needs to happen here is that this 8 needs to be multiplied to the 3 and the 2i. And this I needs to be multiplied to the 3 and the 2i as well. So as long as you remember somehow that you have to do 4 different multiplication processes, I don't care how you do it. Alright, so for the purposes of showing you, I'm also going to do the FOIL for this particular problem. So I'm going to show you a lot of different methods of remembering how to distribute correctly, and it's up to you to choose which one you like. Alright, so FOIL says multiply the first. That'd be 8 and 3 is 24. The outside terms are 8 and 2i, so 8 times 2i is 16i. The inner terms are I and 3, so 3 times I is 3i. In this way, you're actually treating I like a variable, like x, y, or z, but just know that it's not really a variable. Alright, and then I times 2i is 2i squared. Do you see that we've now got this I squared? This is the reason for me saying that I squared is equal to -1. We're actually going to have to change this. If I squared is really -1, then the last term is 2 times -1, or -2. So what we have to do here is we now have to combine like terms. I have a real part, 24, and -2, and that will give me 22. I also have imaginary parts, 16i and 3i, which add to 19i. So multiplication relies on you understanding the distributive property, but also understanding the adding that we did in the last video. Alright, so let's do some more practice problems, because practicing is where we are going to learn it. We did FOIL in the last one, so let's do the box method for this one. Alright, So we have 3 minus 2i and negative 6 plus 5i. And notice that I'm carrying the signs with me. That way I don't forget what's plus, what's minus. So negative 6 times 3 is negative 18. Negative 6 times negative 2i is going to be positive 12i, because negative times a negative is a positive. 5i times 3 is 15i. And 5i times negative 2i, 5 times negative 2 is negative 10, I times I is I squared. So we're actually going to have to change this I squared here to a negative 10 times negative 1, which is a positive 10. Now, with this being a positive 10, if you look, our real parts are here, negative 18 and positive 10. So that will give us negative 8. Our imaginary parts are diagonal from each other as well, so 15 i's and 12 i's is going to give me 27i. So negative 8 plus 27i is the answer for the multiplication problem of these two complex numbers. Alright, so what I'd like for you to do is pause. Either use the FOIL method, use the box method, or just simply distributing the first complex number onto the second and multiply these two complex numbers. So give it a shot, pause, and see how you do. Alright, so if I distribute the negative 3 to the 8 and the 5i, negative 3 times 8 is negative 24. Negative 3 times 5i is 15i. Oops, that would be a negative 15i because it's a negative 3. Alright, then I multiply the I to the 8, so that would be 8i. And I to the 5i would be plus 5i squared. Anytime we have I squared, though, we need to change this. So the I squared is simply going to change to 5 times negative 1 or negative 5. So this becomes an addition problem. Negative 24 plus negative 5 is negative 29. Then we have negative 15i plus 8i, negative 15 minus 7i. And that's the answer to that one. Alright, let's do one more practice example. And this one I'll use FOIL. How about that? FOIL. Now I know a lot of people, it's just how to remember to multiply correctly. That way you don't forget it. Some people don't like the word FOIL. Just remember it's an acronym to help you distribute correctly. Alright, so the first term is 3 and negative 5, so that's negative 15. The outer terms are 3 and negative 9i, so that's negative 27i. The inner terms are negative 2i and negative 5, so that's a plus 10i. And then the last terms are negative 2i and negative 9i, so negative 2, negative 9 is positive 18, and I times I is I squared. This is going to change to a negative 18 because of the I squared. Alright, so negative 15 plus a negative 18 is going to give me a negative 33. Then I have my negative 27i and my 10i, so that's negative 17i. And that's it. Now occasionally when we multiply complex numbers, it's not going to be two complex numbers multiplied to each other. Sometimes it's going to be a real part that gets distributed in to the complex number. Alright, so we're working on this problem, and this is actually the second time I've got interrupted making this video. I don't know what it is about this video, but this is twice that someone has knocked on my door and wanted to know a question. So maybe tomorrow I'll ask you, how many times was I interrupted, and you'll say 2, okay? Alright, so let's get back to the problem at hand. Pardon me while I get my brain reoriented from being disrupted. Okay, so we need to distribute the negative 3 to the 2 and the negative I. So negative 3 times 2 is negative 6. Negative 3 times negative I is a positive 3i because two negatives multiply to a positive. Alright, now in this problem we're going to end up with a very different answer. Okay, so we still have two complex numbers that we need to multiply, so you can either use the box or the FOIL, whichever you prefer. I think I've done FOIL more than I've done box, so let's do box for this one. You can do it however you like. So I have 4 plus 3i and 4 minus 3i. So when I multiply this, 4 times 4 is 16, 4 times 3i is 12i, 4 times negative 3i is negative 12i, and negative 3i plus 3i is negative 9i squared, which we know that negative 9i squared is really negative 9 times negative 1, or positive 9. So what's going to happen here is you'll notice that these opposites, the diagonals from each other, are like terms. 16 plus 9 is 25, 12i plus negative 12i is 0i. So I'm left with just 25. Now here's what's important about this. You'll notice that we just ended up with a real solution. It wasn't imaginary, it wasn't complex, it was real. I can hold 25 apples or whatever in my hand. Now if you'll notice, all I had to do was take the same complex number and change the sign, and I got rid of my imaginary part. This is what we call conjugates. This second complex number is a conjugate to the first, and the first complex number is a conjugate to a second. They are conjugates of each other. This is going to be important when we talk about division of complex numbers in our next video. But for now, we are just focusing on multiplication, so I hope you have everything that you need, and I will see you later.